Have you ever noticed how certain words just completely hijack the cultural conversation?
Oh, absolutely. Like overnight.
Right. You're scrolling through your feed or you're sitting in a strategy meeting and suddenly everything is green this or eco that.
Yeah, green technology, clean technology, eco technology, it's everywhere.
It gets thrown around with such frequency that it becomes almost, I don't know, invisible. Like you start to wonder if there's any actual engineering behind the marketing gimmick.
Which is a totally fair question.
Well, that is exactly what we're going to figure out today. Welcome to our deep dive. We're looking at a comprehensive breakdown of this entire sector, moving past the buzzwords to understand the actual mechanics of how this stuff works.
And why it's fundamentally rewiring our world, really.
Exactly.
Yeah.
We're going to impartially report on what the source material lays out, not endorsing any specific policies, but just showing you the blueprint of these ideas. Okay, let's unpack this.
It's a crucial topic to unpack because, honestly, we are looking at a massive paradigm shift. It's not just a passing trend. When we talk about green technology or clean tech, the baseline assumption you probably have is that we are discussing innovations designed to, reduce human impact on the environment.
Which is the obvious part.
Yeah, but there is a secondary, equally critical mandate built into the DNA of this field, according to our sources.
Yeah.
And it completely changes how we should look at it.
Right, and that dual mandate is really the hook for me. I mean, the primary goal is obviously tackling the existential stuff.
Climate change, pollution, resource depletion.
Exactly. But the underlying architecture of green tech is designed to solve those problems while aggressively promoting economic growth and human well-being.
It is trying to prove that sustainability and profitability are not mutually exclusive.
What's fascinating here is that historically, industry operates on a trade-off model. The assumption was always that protecting the environment inherently required economic sacrifice.
You had to choose between a healthy biosphere and a thriving GDP.
Right. But green tech completely rejects that premise. It's an engineering philosophy that says we can build an economy that thrives specifically because it is hyper-efficient.
It's about innovating forward, not moving backward to some pre-industrial state.
That makes a lot of sense conceptually, but to really grasp how you execute a dual mandate across a complex global economy, I think we have to look at the engine of the modern world.
The power grid.
We have to start with power generation. And look, you don't need us to explain why solar, wind, hydro, and geothermal power are better than burning coal.
No, I think everyone listening knows that renewables don't deplete finite resources.
And they don't pump carbon into the atmosphere.
Uh-huh.
But the generation of the power is actually the easy part, isn't it?
It really is. The fundamental engineering bottleneck of renewable energy isn't catching the sunlight. It's the intermittency problem.
Right, because the sun sets.
Exactly. Our entire legacy electrical grid was built for constant, predictable baseload power. You shovel a specific amount of coal into a furnace, you get a specific, predictable output of electricity.
But the sun goes behind a cloud or the wind dies down, and suddenly your generation drops off a cliff.
And the grid operates on a strict, constant frequency. If supply and demand don't perfectly match second by second, the whole system destabilizes.
So having a million wind turbines doesn't actually help if you can't manage that fluctuating supply.
No, it can actually be a liability.
Right. It's like if the traditional power grid is basically a dumb pipe just pushing water blindly in one direction, modern smart grids have to be like a highly intelligent traffic control system.
That is a great way to look at it. They are essentially highly complex, data-driven nervous systems.
How so?
Well, smart grids use real-time sensors and predictive algorithms to dynamically balance the load. Instead of just reacting to power drops, they predict them.
Oh, wow.
Yeah. So if a weather system is moving over a major solar array, the smart grid algorithms anticipate the drop in voltage.
Before it even happens.
Right. And it instantaneously signals other nodes in the network, maybe a hydroelectric facility miles away, to spin up and fill the gap.
Before a human operator even registers the cloud cover. That's wild.
And they manage the demand side, too. If the grid is stressed, a smart grid can communicate with, say, the smart thermostat in your house.
Or your electric water heater.
Exactly. And it just delays its cycle by 3 minutes, you don't even notice, but multiplied by millions of homes, it instantly shaves off the peak demand.
So the intelligence of the grid is what actually allows renewable energy to scale.
It's bidirectional communication, but that brings up a really vital point from the text.
What's that?
You can generate perfectly clean energy, and you can route it with an incredibly sophisticated algorithm, but if the end destination is a wildly inefficient building, you are still failing the efficiency mandate.
Which brings us to where we spend 90% of our lives, the built environment.
Yes.
Now, let me push back on the popular image of this because I think there's a huge misconception here.
Okay, let's hear it.
When most people hear green building design, I think they picture a standard glass and steel office block that just has a few solar panels slapped on the roof.
And maybe some low-flow toilets.
Exactly. But looking at the mechanics of this in the source material, that is just window dressing.
It absolutely is. True green building design isn't an add-on. It is baked into the structural physics of the building.
If we connect this to the bigger picture.
If we connect this to the bigger picture, it starts with passive thermal design.
Passive thermal design, meaning what exactly?
An optimized building uses high-density materials thermal mass to naturally absorb heat during the day and slowly release it at night.
Oh, I see.
It also uses the physical orientation of the building to maximize natural light while minimizing the harsh glare that requires heavy air conditioning.
So the architecture itself acts as a battery, basically regulating its own temperature before the HVAC system even has to turn on.
Precisely. And when the active systems do kick in, they are radically different.
Right, like we're talking about outfitting spaces with next-generation insulation.
And intelligent LED arrays that adjust to ambient light, and high-efficiency appliances that pull a fraction of the wattage.
And all these technologies compound. So a well-designed green building demands exponentially less energy from that smart grid we just talked about.
It's all connected.
Okay, so the building is a lean green machine. But what about the stuff flowing out of the back of that building?
You mean waste?
I'm talking about waste. This field puts a massive emphasis on waste management, recycling, and composting as core components of green tech.
Because waste is ultimately just a catastrophic failure of design.
Wow, that's a strong way to put it.
Well, think about it. In nature, there is no waste. The byproduct of one system is the fuel for another.
So composting and advanced recycling are essentially trying to mimic that closed-loop biological system.
Exactly. But where green tech gets really aggressive is in changing the molecular nature of the waste itself, particularly with biodegradable materials.
Like biodegradable plastics. Let's dig into the mechanism there, because it's not magic, right?
No, it's chemistry.
Because traditional plastic is a polymer chain that is so tightly bonded, nature simply doesn't have the biological tools to break it apart.
Right, it just sits in a landfill for 1,000 years.
So how does green tech actually change that?
By engineering the polymer chains with deliberate vulnerabilities.
Oh, fascinating.
Yeah, things like polylactic acid or PLA, which is derived from fermented plant starch, like corn.
Okay.
The chemical bonds in these bioplastics are specifically designed to be recognized and cleaved by the enzymes produced by naturally occurring microbes.
Wait, really? So under the right composting conditions, those microbes literally digest the plastic?
They do. They break it down into harmless lactic acid, carbon dioxide, and water.
You're programming the material to self-destruct organically.
That's exactly what it is.
That is brilliant. So we've optimized our power, our grids, our buildings, and even the molecular structure of our trash.
But eventually, you have to leave that hyper-efficient building.
Right. You have to move through the world. Let's talk about transportation.
This is where we see some of the most rapid commercial deployment. Electric and hybrid vehicles are replacing the internal combustion engine.
Fundamentally shifting transportation away from localized fossil fuel emissions.
Because EVs convert electrical energy into kinetic energy with incredible efficiency compared to a gas engine. A gas engine wastes most of its energy as heat.
But wait, let me challenge this for a second.
Go for it.
Replacing a gas-guzzling traffic jam with a silent electric traffic jam doesn't actually solve the problem of urban congestion, does it?
Not at all.
Like if I'm sitting in gridlock in an EV, the air in the city might be a bit cleaner, but we still have thousands of 2-ton metal boxes clogging up the physical space of the city, sitting idle.
Which isn't a systemic solution.
Exactly.
You've hit on the exact limitation of simply swapping drivetrains. You can't just change the fuel. You have to change the spatial geometry of the city.
Which the source mentions.
Right. That's why transportation alternatives are a massive pillar of green tech. We are talking about the integration of micromobility.
Dockless electric scooters, bike-sharing networks, electrified public transit.
Right, because moving a 200-pound human 2 miles down the road shouldn't require moving 4,000 pounds of steel along with them.
It's just bad math.
Exactly.
Yeah.
Micromobility fills the last-mile gap, allowing people to navigate dense urban centers without the spatial footprint of a car.
But there is a secondary mechanism here that connects transportation right back to our first topic.
Oh, the batteries.
Yes, those electric vehicles sitting in the city, they aren't just cars. They are highly mobile, high-capacity batteries.
Vehicle-to-grid integration, V2G.
Yes. When those EVs are plugged in at the office or at home, they can bidirectionally communicate with the smart grid.
So if a sudden peak in power demand hits the city at 2 p.m.,
The smart grid can pull a tiny fraction of power from thousands of parked EVs simultaneously to stabilize the system.
and then charge them back up when demand drops at night.
So the cars become a decentralized, distributed power plant for the city.
That is an incredible conceptual bridge.
We've been focusing heavily on human infrastructure so far: cities, grids, cars, buildings.
But green tech isn't just about human spaces. It's also about applying this rigorous engineering to the natural world itself.
Here's where it gets really interesting.
It does, because the scale moves from the urban environment out to planetary ecosystems. Agriculture is a prime example here.
Because the mandate isn't just a nostalgic return to old-school farming.
No, it's the deployment of precision agriculture.
We're applying data science to dirt.
Literally. Precision agriculture uses IoT sensors in the soil, paired with multispectral imaging from drones and satellites, to map a farm down to the square centimeter.
So instead of a tractor blindly spraying thousands of gallons of fertilizer or water across an entire field,
The system knows exactly which individual plants are nitrogen deficient or dehydrated.
it's like microdosing the crops,
Yes, you only deploy the exact chemical or water payload needed exactly where it's needed.
which massively reduces agricultural runoff and conserves water.
Exactly.
Speaking of water, how is green tech approaching wastewater? Because the traditional method is, frankly, incredibly brutal and energy intensive.
The traditional model is highly centralized. You pipe millions of gallons of sewage miles away to a massive facility.
And you hit it with heavy industrial chemicals and physical aeration to sanitize it.
Right. Green tech is moving toward decentralized water purification and biological wastewater treatment.
Meaning biomimicry.
Exactly. Using engineered membrane bioreactors where specific cultivated colonies of bacteria are used to consume the organic waste and nitrates in the water.
You are essentially creating hyper-accelerated artificial wetlands locally.
Purifying the water at the neighborhood or even the building level, using biology instead of brute force chemistry.
Well, let's talk about chemistry, actually.
Yeah.
Because there are two concepts here from the text that really tie the environmental remediation side together.
Carbon capture and green chemistry.
First, carbon capture and storage, or CCS. Often, when people talk about carbon capture, the analogy used is a giant, high-tech vacuum cleaner sucking CO2 out of the air.
Yeah, but from an engineering standpoint, it's much more elegant than that. The vacuum analogy implies you are just mechanically filtering dust.
Right.
Carbon capture is a complex chemical separation process.
So it's less like a vacuum cleaner and more like a molecular bouncer at a nightclub.
I like that.
In a system like amine scrubbing, which is attached directly to industrial smokestacks, the flue gas is passed through a liquid solvent containing allanine compounds.
And the allanines act as the bouncer.
Exactly. They specifically recognize and chemically bind to the carbon dioxide molecules, holding onto them, while letting the harmless nitrogen and water vapor walk right out the door and up the chimney.
Then you heat up the solvent, release the pure CO2, compress it, and inject it deep underground.
That is a much more accurate way to visualize the mechanism. It's targeted interception.
And it pairs philosophically with another incredibly important discipline from our source, green chemistry.
Which sounds like an oxymoron to a lot of people.
I know, but it is one of the most vital fields in manufacturing right now. If carbon capture is about intercepting the poison before it escapes.
Green chemistry is about designing the poison out of the process entirely.
Yes. It focuses on a concept called atom economy. In traditional chemistry, if you mix ingredients to create a pharmaceutical or a dye, you might end up with the product you want, plus a massive amount of highly toxic liquid byproduct that has to be disposed of.
You get the yield, but the collateral damage is high.
Exactly. Green chemistry redesigns the chemical reaction from scratch. It looks for new, benign catalysts that lower the activation energy required for the reaction.
Allowing it to happen at room temperature instead of requiring massive industrial heat.
Right. It uses water or supercritical carbon dioxide as a solvent instead of toxic petrochemicals.
So the goal is to design a reaction where almost every single atom you start with ends up in the final product.
Leaving zero toxic waste behind, it's prevention at the atomic level.
Man, so we are intervening everywhere. We are scrubbing the smoke at the stack. We are redesigning the molecular catalysts in our factories. We are microdosing our crops from space.
And turning our cars into a giant decentralized battery.
But how do we actually know if all this orchestration is working? How do we verify that the biosphere is healing?
That is where environmental monitoring and sensor networks come in. We are deploying advanced, ruggedized IoT sensors into the wild.
Like digital park rangers.
Yeah. They are constantly measuring water turbidity in remote rivers, tracking air quality metrics in real time across urban grids.
And even using acoustic sensors to monitor biodiversity and the health of wildlife populations in dense forests. So what does this all mean? We've covered a massive amount of ground here, from smart grid load balancing to the enzymatic breakdown of bioplastics.
All the way to amine scrubbing and precision agriculture.
If you had to synthesize the ultimate takeaway for everyone listening right now, what is the core message of this deep dive?
The core message is that green technology has matured far beyond a niche environmental movement. It is cross-industry, global evolution of our core infrastructure.
It is addressing our most severe environmental challenges and the reality of resource scarcity.
But the ultimate takeaway goes right back to that dual mandate we opened with. This evolution brings massive economic benefits.
Right.
By driving energy efficiency, creating entirely new engineering sectors, and optimizing how we use every single raw material, green technology proves that sustainable development is simply the most logical, profitable form of development.
It's the only operating system for the global economy that actually scales without crashing the hardware.
That's a great way to put it. But this raises an important question, something that ties several of these seemingly separate threads together.
What's that?
Think about those advanced environmental sensors we just discussed, the ones sitting out in the remote wilderness.
The ones tracking biodiversity and water quality.
Right. Now, combine that capability with the concept of the smart grid, the highly intelligent, predictive, data-driven network managing our cities.
Okay, I'm tracking.
If we are placing millions of advanced sensors out in the wild to constantly stream data on the health of ecosystems, and we are connecting our human infrastructure to intelligent, responsive algorithms, are we heading toward a future where nature itself is fully plugged in?
Wow.
Imagine a world where we have a real-time, global, digital dashboard for the health of the entire planet's biosphere.
That is heavy.
A scenario where the line between the natural world and technology is completely blurred, not to pave over nature, but to meticulously sustain it.
It's a profound shift in how our species interacts with the planet.
And definitely something to ponder as you go about your day.